Hey everyone! Today we are going to talk about rational expressions. Before we do, let's recall what a rational number is. A rational number is something that can be written as the ratio of two integers. So for example, we have 1 over 3. That's a ratio of two integers. If your ratio can be written as two integers, then it either terminates or repeats. So, for example, 1/3 is also known as 0.3 repeating, whereas the fraction 1 to 2 is equivalent to 0.5. So, just a little refresher on rational numbers. If you can be expressed as the ratio of two integers, you're either a repeating decimal or a terminating decimal. Now, let's just consider what has to be done in order to simplify a rational number. This will help us understand rational expressions. So, looking at example 1 here, we want to think in terms of factoring the numerator and the denominator, and then canceling common factors. So, the denominator, 24, we should recognize that it could be equivalent to 3 times 8. So if I express the denominator as 3 times 8, we understand that this fraction simplifies to 1 to 8 because of the common factor of a 3 being canceled. So my answer is 1/8. Again, that seems straightforward, and we should be able to do that with ease. But let's think about the process that we take in order to simplify 3 over 24 to 1 to 8. This process will help us understand simplifying rational expressions. Let's do number 2 as well. 27 and 81 in the denominator. Well, 27 can be expressed as 27 times 1, whereas 81 is the same thing as 27 times 3. Now, we should recognize that because we've recently been talking about powers of 3. So the 27s cancel, and we end up with 1/3. So 1/3 is my answer for number 2. Number 3, 16. Again, the denominator is equivalent to 4 times 16. And in the numerator, we still have that 16. So we're going to cancel the 16s and recognize that 64 was equivalent to 4 times 16. Therefore, the common factor of a 16 cancels. What factors are we left with? We're left with a 1 on the top and a 4 on the bottom. That's why our fraction reduces to 1/4. Let's take this understanding of simplifying fractions to simplifying rational expressions. Let's define what a rational expression is. A rational expression is the ratio of two polynomials. And we have 3 examples right here. So for example, 3xy is considered a polynomial. It's a one-term polynomial, which we call monomials. In the denominator, we have 5z, which is also a monomial. So since this is expressed as the ratio of two polynomials, this is a rational expression. Likewise here, I have x plus 2 in the numerator, which is a binomial. X plus 5 in the denominator. I have a ratio of two binomials, x plus 2 divided by x plus 5. Over here, 2y minus 1 is my numerator polynomial, and 3y plus 5 is my denominator polynomial. So these are 3 examples of what we call a rational expression. So we're going to focus on simplifying rational expressions today. Let's think in terms of our exponent rules for variables and factoring our numerical factors. The whole objective is to cancel common factors from the numerator and the denominator. In order to establish those common factors, we've got to factor our numerator and denominator. So let's think of our numerator in terms of 2 times x to the third, thinking of our exponent rules. In the denominator, let's express 2 times 3 to be the equivalent of 6 times x times y to the third. Now remember, I was able to separate my x to the fourth as x times x to the third because of our exponent rules. Now, let's cancel common factors. Notice everything in the numerator is separated by just a multiplication operation. That's why it's possible to cancel my 2's and to cancel this x factor. What am I left over with in the numerator? I'm left over with an x cubed over 3y cubed. That's my simplified rational expression. Again, what is our goal? To factor the numerator and the denominator and cancel common factors. Let's carry this on. Say I have something like negative 2 times x squared y all raised to the third. This is where review of our exponent rules will come into play. Negative 2 raised to the third power is equivalent to 8 because negative 2 times negative 2 times negative 2 is 8. Sorry, a negative 8 because we have an odd exponent. A negative raised to an odd exponent is negative. Then we have x squared. Recall from our exponent rules that something like x squared raised to the third is equivalent to x to the sixth. So I'll write that as x to the sixth. Then I have y raised to the third. Simply rewrite that as y to the third. In the denominator, I have 8xy squared. Since I have a monomial divided by a monomial, I can actually utilize my exponent rules in order to simplify. Again, remember, if the numerator exponent is larger, we subtract the denominator exponent from it. So we know that our answer is going to be negative 8x to the fifth, y to the 1, since I have 3 minus 2, all over 1. Now, I'm just going to write that as negative 8x to the fifth times y. But just to think in terms of canceling common factors to help set up for understanding of our polynomials that will simplify, I'm actually going to factor my numerator. So let's do that. I'm going to write this as negative 1 times 8 times x to the fifth times y to the second. And in the denominator, I have an 8, x to the 1, y squared. I'm going to cancel all of my common factors from the numerator and the denominator. The 8's cancel, the x's cancel, the y squared cancels, and I'm left with, as we already knew, negative x to the fifth, y. Now, the reason I did it this way was so we can understand better how to simplify rational expressions that are polynomials. For example, number 6 here. We have been factoring polynomials lately. So the first thing we should recognize in the numerator is that 8y minus 4 has a common factor of a 4. We take that out by undistributing. So I've got 4 times 2y minus 1. In the denominator, notice that I've got this binomial 12y plus 20. They have a common factor of a 4 as well. Let's take that 4 out, and I'm left with a 3y plus 5. Let me fix that y. Now I've got two factors in the numerator, a 4 times a 2y minus 1. In the denominator, two factors, a 4 and a 3y plus 5. We can only cancel things that are separated by multiplication. So the 4's cancel. However, the binomial of a 2y minus 1 is not the same thing as my 3y plus 5. Therefore, I've got to simplify by rewriting my expression as just 2y minus 1 over 3y plus 5. That's my simplified answer. I cannot cancel anything any longer. Let's consider something like number 7. Again, thinking in terms of factoring our numerator and our denominator, we should recognize that we have a common factor of a 2 to take out. So I'll write the top as 2 times x plus 2. In the denominator, that is a 3 for a common factor, left with x plus 2. I've got two factors in the numerator. 2 is my numerical factor, and my binomial factor is an x plus 2. In the denominator, I've got a numerical factor of a 3 and x plus 2. Since x plus 2 is the same as x plus 2 in the denominator, these are binomial factors that I'm allowed to cancel. Therefore, my simplified answer is 2/3. Number 8. Now we have a rational expression that has a trinomial in the numerator and a trinomial in the denominator. Let's factor. Now I have a leading coefficient that is 1, so I know the only way I can factor the front terms are x and x. Then let's factor based on looking at factors of 6 that get me a sum of 5. That would be positive 2, positive 3. And then in the denominator, again, I have a trinomial whose leading coefficient is 1. The only way of factoring that is x and x. Now let's consider factors of 9 whose sum is 6. 9 and 1, 3 and 3. That would be 3 and a 3, guys. Plus, plus, since my middle sign is a plus. Now I've got two binomial factors on the top, separated by just multiplication, separated by just multiplication in the denominator. We can cancel common binomial factors. So I'm going to get my x plus 3 to cancel from the top and the bottom, and I'm left with x plus 2 over x plus 3. Let's do another one, guys. Number 9 here. I have x squared minus 25. We should recognize that as one of our special polynomials that represents a difference of 2 squares. The pattern for factoring that is to take the square root of the first term and the square root of the last term, and then plus minus. We can always do a quick mental check back by doing a FOIL. We've got our x squared, the outer product is a negative 5x, the inner product is a positive 5x, which cancel, and we're left with minus 25. Now let's factor the denominator. Again, I've got a trinomial whose leading coefficient is x squared. The only way of factoring that is x and x. Then let's factor by looking at factors of 10 whose difference is positive 3. So we either have 1 and 10 or 2 and 5. 2 and 5 is the one that we want. And since our middle sign is positive, we want the bigger number or the bigger product to be positive. So I have a binomial of an x plus 5 on top multiplied to x minus 5. On the bottom I have a binomial of x minus 2 times x plus 5. So we cancel the binomial factors that are in common. X plus 5 cancels with my x plus 5, and I'm left with binomial x minus 5 over x minus 2. This is as good as we can get for simplifying. Do not be tempted to cancel the x's from the numerator and the denominator at this point, which is a common error. The x's on the top and the bottom are attached to the 5 and the 2 by subtraction, not multiplication. So our simplified answer is x minus 5 over x minus 2. This concludes our lesson for today on simplifying rational expressions.
Made with Doodlecast Pro.